Hello everybody. Today I'm going to be going over arithmetic series. So if you remember arithmetic sequences from grade 11, that was essentially when we had a sequence of values where we had a constant difference for every single value in that sequence. So if we had a case where we had about, let's say, 12, then we had the next value which was 6, then we had the next value which was 0, then negative 6, then blah blah blah. This would have a constant difference of subtracting by 6 every single time. Each and every single time. That means our difference would be equal to negative 6. Our first term, which is a, is represented by 12. And obviously n would be the number of terms that we are working with. And this would be n amount of terms. But now, we are not really focusing on that. Now, we are going to be focusing on series. And series is essentially, instead of having these semicolons, we are just going to have a series of values which is adding each other each and every single time. So yeah, let's get into that. But first, before we get into the actual problems that we must face, let's do the proof. Let's actually derive these formula that we're going to be working with. Okay, so first things first, this is how you're going to start. So I'm going to give you a step-by-step procedure on how to actually prove this thing. I wouldn't expect you to know everything, but just understand the process. So we notated by S of n. You know, when we had T of n, it was like the number of terms, right? The nth term, sorry. But now this is the nth series, meaning we are adding all of the terms an n amount of times. So we're taking term number 1 and we're adding with term number 2, adding with term number 3, we're adding it all the way until we get to term number n, the nth term. And that is how we denote this first part over here. Okay, but the question is, what is term 1? What is term 2? Remember that term 1 is denoted by a, and term 2 is denoted by a plus d, because remember we're adding that difference, and then that would indicate that term 3 is denoted by term a plus 2d, right? And then it goes all the way until tn is equal to a plus n minus 1 into d. Okay, so therefore this just implies to us that s of n, sn, s sub n, whatever, right, the series to n terms is just going to be the same as a plus d, just going to do the substitution, plus a plus 2d all the way and adding until we get to a point of a plus n minus 1 into d. Okay, so that is where we're going to stop from this Sn. But here's the thing, right? We are going to do something different. We are going to let the last term, which is going to be a plus n minus 1 into d, equal to L. L is denoted by the last term. So I'm going to say where L is last term. Okay. This is just how we get the proof. This is how the proof was done, and I'm just repeating, okay? Such that what we're going to have is Sn is equal to a plus d plus a plus 2d plus dot 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 all the way to, okay, think about this. We're going to get to the last term, right? Because remember, this whole thing is L. But we want to consider the part of the series before L, which means we are subtracting d, right? And then the next one is when we're going all the way to the actual final term, which is L. So this minus d is essentially a step back when you're minusing d instead of adding d. So we go in the opposite direction. Hopefully that clarifies things. Okay, and then let's call this equation 1. So I'm going to label this equation number 1. And then what I'm going to do is I'm going to set, set equation, or I guess another way we can say this is reverse order of 1 to get a new equation, okay, such that what we get from here is when we reverse the order, it's Sn equals to L plus L minus D plus dot 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 plus A plus 2D plus A plus D plus A. Okay, so and then we call this equation 2. And then what is going to happen from here? We are going to add equation 1 with equation 2. So we're going to say here, add 1 and 2. Okay. Such that what we are going to get is going to be 2 times S sub n, which is equal to, and you'll get to a point where we'll have A plus L plus A plus L plus dot 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 plus A plus L plus A plus L. Okay, so if you think about this, right, you'll get the A's to be an n to appear an n amount of times, and an L to appear an n amount of times. So A plus L appearing an n amount of times, because that is how we denote this. This appears, so I'm going to write down here, appears in amount of times. Okay, it's in amount of times, such that when we take a common factor of n, then we're going to get n as a common factor into A plus L. And then obviously, since we took that common factor out of A plus L an n amount of times, this is what we are left with. And then we can solve for Sn by dividing both sides by 2. And then we're going to be left with Sn is equal to n over 2 multiplied by A plus L. Okay. So here's our first equation for Sn. And this equation is usually used when last term is known. So when you know the last term of the series, we will use this equation. But what about the other one? Remember, we let L be equal to this A plus n minus 1 into n. So what if we substitute back? So therefore, what that tells us is we're going to also have a second equation, which is Sn equals to n over 2 into A plus, and remember L is equal to what? L is just equal to A plus n minus 1 into D. Okay, and then therefore we say that Sn is just equal to n over 2 into A plus A is just going to be 2A plus n minus 1 into D. And then this is used when the last term is unknown. Okay, so when the last term is unknown, we will use the second equation. Okay, so now that we know what to use, let's get straight into examples and see what we can do. Alright, here's our first example. Evaluate the following. So we have 20 plus 17 plus 14 all the way to 500 terms. Oh my goodness. For number A. And then number B is minus 14, negative 14 minus 10 minus 6 minus dot 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 all the way to 80 terms. Are we going to explicitly write every single term down? Absolutely not. That sounds like a waste of time. So first things first, we need to determine using our equation. What is our equation? Well, because we don't know what the last term is, we're going to use the second formula where Sn is equal to n over 2 into 2a plus n minus 1 into d. Okay. So what do we need to do? We need to know what is n equal to, what is a, and what is d. So the n obviously is shared with each other, but we need to really determine what is a and what is d, because why? In this case over here, we know to 500 terms means we need to take the sum to 500 terms. Essentially, we are trying to find out what is s to 500 terms, right? The sum to 500. Okay. Meaning we replaced n with what? 500 divided by 2 into what? A. How do we find a? We know a is just going to be the first term, which is 20. So 2 into 20 plus, and we know n is equal to 500, so it's 500 minus 1 multiplied by d. What is d? D is essentially just the difference between the one term and the term before it. But the question is, how did we know that this is actually arithmetic though? First things first, to prove that it's arithmetic, it has to have a constant difference. So which means term 2 minus term 1 must be equal to term 3 minus term 2. What is term 2 minus term 1? It's essentially just what? So we know term 1 is equal to 20, term 2 is 17, term 3 is just equal to 14. Term 2 is equal to 17 minus 20. And then term 3 is just 14 minus term 2, which is 17. 17 minus 20 is equal to negative 3. 14 minus 17 is negative 3. So since the two are the same, therefore it is arithmetic. Okay. Then we can actually use this formula. That is when it is valid to use that formula. Okay. So please make sure to check. We'll check in the next one. And then D is obviously negative 3, as we've just proven now, to be the difference of the terms. And then if we just put this in a calculator, so sum to 500 terms is just equal to what? If we put it on a calculator, the value that we are going to get, according to what I have, is going to be negative 364,250. Jeez, imagine adding every single one of these terms together. It would have been insane. Alright, so that was number A, and I forgot to indicate that there. But now we can go to number B. Now before we just go straight to the formula, we need to see, is it arithmetic? Because I could have just changed it. The difference to get from negative 14 until negative 10, we actually need to check using the equations from here. Okay, so let's do this. Okay. Notice that negative 14 is term 1, negative 10 is term 2, and negative 6 is term 3. So therefore, we need to prove that term 2 minus term 1 is equal to term 3 minus term 2, right? Term 2 is negative 10 minus term 1, which is negative 14, equals to term 3, which is negative 6, minus negative 10, which is term 2, obviously. Negative 10 minus 14, which is just negative 10 plus 14, which is the same as 14 minus 10, is just positive 4. And then negative 6 plus 10, because it's negative and negative, will give us positive 4. So because they're both the same, and therefore it is arithmetic, okay? And therefore we could use that formula that we want, and because we don't know what the final term is, we're going to use the second equation that we used in the previous one. So Sn equals to n over 2 multiplied by 2a plus n minus 1 into d. Okay, and now we just need to know what is a and what is d and what is n. We know that n is just 80 because we're doing it the sum to 80 terms. So this implies to us that we are doing sum to 80 terms. And then 80 over 2 is what we start with. And 2 into, what is our a value? Our a value is our first term, which is negative 14. plus, and then it will be 80 minus 1, multiplied by the difference, which is 4, which we found. And therefore, we can just plug this in. The sum to 80 terms, according to what I have, is 11,520. Okay. So this is going to be the answer to our problem. Alright. Was it difficult? Absolutely not. Alright, so I want to take you back quickly to something that is very important. Remember when we started our proof and said that Sn is just equal to a plus d plus all the way to I think it was a plus n minus 1 d. Okay, so something like that, right? Remember when we had something like that? Okay, this was essentially the same thing as saying Sn equals to term 1 plus term 2 plus dot 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 all the way to t n minus 1 plus t n. Okay, because it goes all the way to n. But the term before it is n minus 1, right? And this is actually just an introduction to something, some other type of question they can ask in the examinations, by the way. So what does this tell us? If it's Sn, it is going to start all the way from 1 until n. But my question is, what is the series of all of these values, excluding Tn? Would this not just tell us that it's the sum from n minus 1 terms, though? Because we're just excluding the nth term now. If we included the nth term, then therefore it will complete our Sn. But if we exclude this, we have Sn minus 1. So what does this tell us? This implies to us that Sn is actually the same thing as saying Sn minus 1 plus Tn, right? And we want to solve for Tn. We want to actually solve for Tn. So what we are going to do is we are going to take Sn minus 1 over, and therefore we have Sn minus Sn minus 1. And that actually makes sense, because the sum of all the terms minus the sum of all the terms before the last one gives us the final and the final term. It will give us the leftover, right? What is left over? So therefore, this is something that you need to also intuitively understand. So our next example actually used this logic. So let's get into the last example for the arithmetic series. Alright, so here's the questions that I was talking about. The sum of the first n terms is Sn equals 3n squared plus 2n plus 1. So the first things first, question A says find S8. So all we're going to do is replace n with 8 for our equation. So S8 is essentially the same as 3 into 8 square plus 2 into 8 plus 1. And 3 times 8 square is just the same as 64. So 3 multiplied by 64, that is a good question. The answer will be in 192. Okay, definitely didn't have to calculate that one. Plus 2 times 8, which is equal to 16, plus 1. So therefore, our answer will be 209. So we just found S8. What about number B? Number B, we need to find S7. So we're just replacing n with 7 now. So 3 into 7 squared plus 2 into 7 plus 1. And then here we have 3 times 7 squared. 7 squared is just 49. And if we just put this on the calculator, because 3 times 49 is just going to be 147. Plus 2 times 7, which is just equal to 14, plus 1. And then the answer for this one is 162. Okay. And now we need to find T8. But my question is, how are we going to find T8? I mean, this is a series, right? But we don't have the series. And we don't have a sequence either. but isn't that the reference that we just used now? That Tn is also the same as Sn minus Sn minus 1. And the question is, so we are going to use, using Tn equals to Sn minus Sn minus 1 at n equals what? 8, right? Because what are we trying to find? T8, the 8th term. This implies to us that we are going to have T8 is equal to S, what is it? Sn, which is 8, minus S, 8 minus 1. Which implies to us that we have T8 is equal to S of 8 minus S of 7. Because 8 minus 1 is 7. But we know what S of 8 is, and that's 209. And we know what S7 is, which is 162. So therefore, this implies to us that the 8th term is just going to be what? It is going to be 209 minus S7, which is 162, and therefore T8 is just going to be equal to 47. So therefore, 8th term is 47. Okay, so this was just a little bit of a sneaky one that they usually put in. They usually ask you in the examinations, but this is intuitive. You need to understand the logic behind it. And it's also good to learn it now, so that when you get in an exam, at least you know what to do. So that is arithmetic series. And next we'll go on to geometric series.